Alright, so at this point you're providing the decoder outputs that are necessary to read the register file. So the register file is reading the two source registers for us and providing those register values on its output. The register file itself is provided with generic input and output names. So register file read enable and read index for two source registers. Those are controlled by the decoder outputs that you just provided, the RS1 and RS2 index in RS1, RS2, and the valids for those indicating that this instruction does indeed need to read those from the register file. So the RS1 valid and RS2 valid are hooked up to the enables for the register file read. The register file output, again generically named as register file read data 1 and 2, and those provide the source 1 and 2 values that are hooked up to the arithmetic logic unit. So your next task will be focused on the arithmetic logic unit, but before we actually look at that, we need a little bit more help from the decoder. We need to know which instruction the ALU needs to operate on. So our next task is to provide these signals to identify which instruction we're executing. So is BLT, is ADDI, is add, saying this is one of those instructions. Decoding the instruction to determine that is based on this table from the RISC-V instruction set reference manual. What this table is showing is that identifying the instruction, at least for these three as it pertains to us, is based on the opcode field and the funct3 field, which we've already extracted. And we're providing this decode bits signal that concatenates those two together. So you can use this decode bits signal to determine which of the three instructions we are. So to start you off, we're providing is BLT, which is determined based on the decode bits equal this particular pattern, which come directly from this table here. Okay. So you'll fill in is ADDI and is add, and then come back when you're finished with that. Alright, so now you're ready to code up the arithmetic logic unit, and this is actually going to be simpler than you'd expect. Since we're only operating on 3 instructions, we only have to worry about these 3 instructions, and in fact the BLT instruction has no result value, so there's nothing to worry about in the arithmetic logic unit for BLT. So we're really only providing add and ADDI, and to get you started we're providing you with the expression for ADDI, so you really only need to provide the add. So the result from the arithmetic logic unit for an ADDI instruction is the sum of the source 1 register value and the immediate field. So we're saying here that using again chain ternary operator to say in the case of the instruction that's an ADDI, this is the result value that we need to provide. And you'll add a similar expression for add. Should be pretty obvious what an add instruction needs to do. It needs to add the 2 source registers. So you'll provide the appropriate syntax to do that, and then that will be our complete arithmetic logic unit as we care about it for this mini CPU. And then come back when you're finished. Alright, so now you've got the result coming out of the arithmetic logic unit, and again we've hooked that up for you to the register file. So the result from the ALU needs to be written back to the register file, and so we've done that hookup.